Hello everyone, myself Mohan case Assistant Professor of IT Department. Here we're going to discuss about the Apache Zookeper in the Big Data Analytics in this lecture series. Uh, Apache Zookeper is an important tool used for Big Data Analytics to solve the large volume of data to analyze. It's an important tool used by the Big Data Analytics. Here we can see how it's working in the Big Data Analytics. Before that we have the simple motivation thing in the race. Normal race we have the players can able to run to reach the target, the running fast to reach the target. Suppose the deadlock maybe happen, it will be collapse. So what makes distributed system coordination and it is difficult. So there might be some difficult, and coordination helps to reach the target by the races, whoever attend the race. So same like that here, given the some example of motivation here. Centers does not know what kind of things they are going to receive. It may be nothing come back, there might be a network failure. So these kind of cases you have to analyze. So for that, typical coordination problems can be normally we can have in this screen, able to see the static configuration, dynamic configuration, and also group membership, leader selection, mutually exclusive access barriers, etc. So this kind of motivation we can have. So next is we can see the what is Zookeper. Zookeper is an important tool used in the Apache. Yes, Zookeper is an important tool used in the Big Data Analytics. It is a distributed coordination service to manage large set of hosts. It will be manage a large set of hosts with a given algorithm. Wow. It is helping to the data analyst who are took place in that analysis. So Zookeper is an important tool we are talking here. So in this screen we can able to see how the it allows distributed process to coordinate with each other through the shared hierarchical name space of data register. For example, we can see in the huge large number of traffic light signals, how the data can be segregated, used by the clusters to coordinate between themselves. SAD with robust synchronization techniques, highly scalable, handles partial failure in distributed system, etc. So in these Zookeper services, we can have naming services, configuration management, cluster management, leader election, locking and synchronization service, and highly reliable data registry. So these are some Zookeper services we are using here. So the next thing is Zookeper operations. We all know create, delete, exist, get axle, then set axles, then this kind of synchronization. So these are some Zookeper operations we are using regularly. So in this Apache Zookeper is important tool we are talking here. Next we can have the characteristics of Zookeper. It is a very simple one, then expressive one, and also we compare to other things. It is highly available because why? Because it runs on collection of machines and is designed to be a highly available, loosely coupled interactions, and also library provides a open source, and also we can have these kind of things we are using in the provide a resource of manager things. So this Zookeper have a more important characteristics compared to other kind of tools. So is Zookeper is we can have the data model here, we can able to see in the screen. So we can have maintains a hierarchical tree of nodes called G nodes, Z nodes or G nodes. G node stores the data and has associated with the ACL. So G node stores generally G node data access is atomic, and a client reading the data stored at a G node entirely or the read or fail. Similarly, a write will replace all the data associated with the G node. G nodes are referenced by path, which in Zookeper represented as a slash delimited characteristics. So these are the Zookeper data model we are talking here. It maintains a hierarchical tree of nodes called G nodes. G node stores the data and has an associated in ACL, and the data access is atomic, and G nodes are referred by path, which in Zookeper are represented by as a slash and delimited characteristics. So these kind of G nodes we have some properties. Here it is an emperable node, and also we have persistent one, sequence numbers, also watches. There are some properties we are looking here. The next thing is architecture. We're talking about the architecture. It follows the client server architecture. Is assemble and also server, server leader, and follower, and client to server. It is a client server architecture. It is commonly we are already discussed the client server architecture in the previous units. So server, one among the other servers, provide all sorts of service to the clients. And the server leader elected as a service startup perform automatic data recovery and for clients. So for one of the server is to follow orders by the pass by leaders. Then client is request from the service from the server. So architecture, Zookeper assembles server follower, client 1, client 2, server loader, server follower, client 1 to client 3, client 4, client 5, client 6. So n number of clients can be used by the server followers, and server loader will be interconnected with these kinds of clients, and easily followed by the Zookeper things. So then Zookeper implementation service can run in two modes: standalone mode, and in production highly availability is achieved through replication. And phase 1 is a leader election, phase 2 is atomic production. It uses protocol job that run in two phases, which will be repeated infinitely. So Zookeper implementation, we can have service can run into two modes. So here these kinds of things we are having. Phase 1 as phase 2, and a leader election we can have. So that is a Zookeper implementation we are talking here. The next is leader selection. A machine is assembled to go through process and other things. Leader selection important thing we are discussing in the Zookeper, Apache Zookeper tool used for the big data analytics. So these kinds can be majorly followed by things. So leader selection can be done here. A cluster with a few hundreds of messages can be clustered in a single thing. We can able to see in the screen that a program that crawls the web, one machine the leaders would coordinate the efforts. It's application logic or coordination logic. A cluster with a few hundred machines can be clustered together. Then atomic broadcast, all write requests are forward to the leader, which broadcasts the update to followers. When majority has pressed the change, leaders commits the update and client gets a response saying the update success. So these are about some few things we have discussed here for the big data analytics Hadoop Apache tool. That is a Zookeper Apache tool used for the big data analytics. We have learned something about Zookeper Apache tool, how it's using, and what are the characteristics, what are the operations behind the Zookeper Apache tool. This is about this lecture series. Thank you for watching. Thank you.